Hello and welcome to a video of CADS RC Pad-based Designer, part of the Smart Designer suite. The programs within our Smart Designer suite cover steel and concrete. Today we're looking at the concrete ones. They're quick to learn, very simple to use. Licenses are all independent, so you don't need to get all the concrete programs at one go. The licensing is cloud-based, so that gives you the flexibility to work in the office or at home because the license itself is through the internet. But we do have dongle and network options still available. Design can be to BS8110 or EC2. They can be used standalone, so you put all the information into the program on its own, or you could link to Frame Analysis, our 3D Max analysis program, and in which case all the loads and combinations will come through directly. There's comprehensive detailing options in the programs and linked to CADS RC for detailing and scheduling. Licenses are permanent, or we can agree some rental agreements with you. So these are the programs in the suite. Just to remind those of you who don't know, there's beams, columns, pile caps, pad bases that we're looking at today, and slabs. CADS RC Base Designer, a few details here. The checks that it does to the British Code and Eurocode are geotech and structural. They can be used, as I said, standalone or linked to A3D Max for bringing in loads and combinations. Biaxial design capability, the moment loads can be put in the X and Y, and also the column can be offset. The load combinations can be either put in directly as factored loads, or there is a capability in the program to generate the combinations with partial safety factors for you. If you do use CADS A3D Max, there's also the capability there to do automatic batch design and common design. So that also may be a good way to work if you've got a large frame. And there's a link to CADS RC for detailing and scheduling, all of which we'll show you in this video. So let's have a look at the program. Okay, so we're in CADS RC Base Designer. I'm going to take you through a couple of examples to Eurocode and British Code just to show you what the features are. Up here we've got the code where we can set Eurocode or British Code. If we choose Eurocode, we've also got the annex that you want to work to, British Annex, Irish Annex, Eurocode. And if we have any particular settings other than these defaults that we want to set up, then we can go to user defined and we can change, in this case it's the maximum crack width. So that's how you set your code up. Here we've got the materials, the soils, the loads, dimensions of the base, which either in auto design will work out for you or you can put them in and check. Equally the reinforcement and the checking in auto design there. That's basically how we go through the program. We can either go into the materials here and then just go directly across the top, or we can tab through at the top here and it brings up the individual screens separately. Depends how you want to work. I think I'll just tab through the top. So we've got the concrete, we've got the strength class here, the aggregate size, checking obviously for the cover to make sure the aggregate's not too big. We've got the Portland cement type, but there's others there. And then the exposure class. This is a cover calculator, so different exposure types. And as you go through them, you can see just changing to different types. It's actually editing the size and the value of the cover that you require. It's all code-based, obviously. You can also see here what is the base going to be cast on. Is it prepared ground or directly against the soil? And that also alters the appropriate cover that you should be using. So we move to reinforcement. So we're using type A 500 and the soils. So as I mentioned, we're doing soil checks in the program for sliding and overturning. You can look at drained and undrained conditions, short and long term. The program then prompts you for the appropriate values, cohesion for instance here if it's undrained. You can also put in the maximum bearing pressure. That will make a big difference to the size of base that you're going to require. Depth to water. There's other options here for ignoring passive resistance if you wish to just ignore it totally. If you don't, it divides the passive resistance by 3 in accordance with the code. These are dimensions. Now, as I say, the program will auto-design, but if we're putting in something that we're checking, let's say for instance that's what we're doing now, then you put your base in, some kind of thickness of the base, a value for the depth, and then you've got the column base. It could be rectangular or circular. I'm going to make it rectangular. Let's say it's 700 by a meter, it's a pretty big column. And then you've got an offset here. I'm going to put in at 750, so you can see it's offset, and we can do it in the X and the Y. Then we've got the bar arrangements. So I'm going to say I think we need top and bottom. It's quite a big base. I've got a bit of pretty big load in. And then we can choose our bars. Let's say we're going to have 16s, top and bottom everywhere. You could also put in the pitch, but I'm going to just keep it at 150 for now. And we can change the shape. So you'll see when the diagram comes up, the default is straight bars. I can edit that to whatever I want it to be. So it could be 0 bars or U bars, 21s. So you can see me toggling it to U bars and applying that. There we go. It's up to you which way you want to go. You can see the area provided. Now there's an auto design control as well. So if you want to prevent the thickness of the base going less than 500, you can lock it. So in other words, that's the minimum dimension, and that's the maximum. So you're actually in some control when it's auto designing. Equally, you could say I want it rectangular and put in some ratio of length to width. You can also here get it to design the bars for you, or you can say I'd rather aim at 16s, that's what I've got on site, or you can leave it to the program. And again, you've got maximum spacing of the bars. So all that's left to do now is put in some loads. So you can see over here we can put those in. Now there's options for this. If we're working with A3D Max, you can bring them in directly. They'd already be here. We wouldn't have to do anything. The loads in this particular screen will be factored loads, which is what I'm going to do. But the alternative is to put loads in here unfactored for dead and wind and imposed loads, and the program will automatically generate the serviceability and ultimate limit states for you. So let's work this way first. We've got new combination. It's really just putting in a load case name. Let's make it capital letters. There we go, load case 1. Just put some numbers in, say 1,000 for that. And you can see me, it's just basically tabbing across. What I'm doing is hitting the return key to move the cursor across. So we've also got the option here for floor loads coming onto the base. Where's the load acting? So it's obviously going to add a moment to the base if it's at the top. We're going to say that the loads have a wind contribution. That's going to affect how the factors applied are going to work. And then we're going to tell it that this is a serviceability. You can see you can change it to whatever you wish it to be. Once we've done one, let's put in another load combination. And this will be our ULS case. So let's have a bit higher values here now, because these are factored loads, remember. 300, 0, 0, make this 400. And again, a bit of a floor load coming in. We've got a wind contribution in there. And this is ultimate limit state. Now you can have stability or just straightforward design sets as we got there. You can also have other loads coming onto the base here. Look, we've got the option to have beams spanning onto your base, either on one side or both sides, as you can see, like so. And then you can put in the distance from the center and the load value. Same with area loads for simulating wall and partition loads coming in. So again, you can have a partial area or a full area, and you've got the input values there that you can edit for the loads coming in. So quite a comprehensive set of loads that you could actually develop. We're just keeping to this for now, so let's apply that. It's actually now saying, do you want me to auto design this for those loads, or do you want to just check it? I'm going to say just check it. So no to that, and then check design, and we go through the list of all the checks it's done here. You can see from the bearing down to reinforcement, which happens to be okay, but up here we've got a problem with the ultimate bearing capacity. You can see it's as a factor of safety it's 2.8 and the limit's 3, so that's failed. And then we've got serviceability. The bearing capacity I put in was 200, so that's failed as well. So we can either, for the bearing capacity, we could change the base manually, just go back in here and type some other figures in. That's possible, no problem at all. But we have this auto design, so it's very tempting. So you just push the button, bang, and everything now passes. You can see we're 96% in there with the bearing capacity, 98.6 with reinforcement, and all these seem to be okay. Let's just check what it's done with the reinforcement. We've got 16s at 225 and 12s at 125 there. You can see, look, obviously because it's biaxial bending. You may say 225s are a bit too big. So again, you could go in here and close that up. It's entirely up to you. If you think that's too big, you can edit it and apply that, and then just do another check. Obviously that works okay, no problem at all. But you can make either individual elemental changes to reinforcement and base sizes and thicknesses and so on, or just hit the auto design and let it work. So there we go, that's a base that's designed. The output, let's go to the print preview. You can have condensed or detailed output. So these are all the various items that you get. And if you want to, you could just put individual titles through. Let's put them all in. We have the option to send to comma and tab formatted files for spreadsheets, for instance, or directly to Word. The pages can be set up by you. This is a page description, a logo you can put in, all open format for you. And then you just hit preview. So we've got 6 pages, and we can look at consecutive pages. This is 1 and 2. There's a little diagram of what we had on the screen. Remember, this is going to link into CADS RC, so that's not just going to be a detailed sketch then. It'll be detailed. And we can just wander through up here, or we can indeed just jump to positions from the menu on the side here. So entirely up to you how you work. No errors, everything's fine. So that's the Eurocode version of the program. I just want to show you the other option in the program, that is the British code. So you can work to 8.10. And the only difference really is the load factors option here. The loads and the dimensions and the controls for auto design and so on, reinforcement, all very similar, slightly different descriptions for reinforcement grades and so on, but that's about it. So let's have a look at the load factors. You can see here the program's asking you whether you want to do an ultimate bearing capacity check. Now the reason it's doing that, it says down here, if the bearing pressure is limited by settlement rather than shear failure, then select not checked. In other words, as we've got it now for a horizontal bearing effect check. So that's what it's going to do as a check. The ratios there are less than 1. So let's leave that on for now. Just a different way of assuming the base is working. The rest of it's pretty much like we had before. Load combinations we put in before, the dimensions as before, and so on. Reinforcement types, pretty much the same. So we could carry on. What I'd like to show you though is the auto combinations feature. It works for Eurocode and British code. So what we're doing here now, as opposed to putting in these combinations as factored loads, we put the loads in as unfactored, working loads in other words, directly from your analysis or from some external source. So you're typing in just values that you've taken from another program possibly, or someone's given you to check. Depends how you're working. Let's put a bit of wind load in. Some arbitrary values there. Look, conventions are shown here, by the way. If you're wondering how you put in a positive rather than a negative moment, for instance, you can see what positive X and Y are here. These are the factors. Obviously it's British code, but Eurocode it would be similar. Serviceability and ultimate limit I want, not just one or the other. And then we hit generate. And you can see now we're back in the screen where we put in our load combinations as factored loads, but it's added now the combinations to the code for serviceability. You can see there are some serviceability state and limit state there, ultimate limit state, and it's done all the factors for me. It's done all the work for me. So we can go to check design. We need quite a bigger base, I think. So we can go to auto design. There we go, and you can see there that's all passed, and everything's fine. You can go to the print preview as we did earlier, do a preview, and you can see, there we go, all the different output pages, and put it into two consecutive pages. No errors. There's all our results. Pass, pass, pass. Nice to see. Checking sliding, overturning, obviously reinforcement required, and so on. There we go. Okay, so that's the program working in standalone mode. Now let's have a look at it linking to A3D Max. Okay, so let's now link the base design from 3D Max into the RC Base Designer. This has been run through, it's all been analyzed. There's a myriad of combinations that the program's generated in here for analysis. You can see across the top. Those are all the combinations we'd manually have to normally type into the base designer. Now I'm going to pick that base and link this through to CADS RC Base Designer so that I avoid having to do all that. So this is telling the program which base to design. It's ported it through. We're in the base designer now, and all those loads, you can see them here for yourselves, have come through. All of the combinations are there, the different types of combination in terms of stability and so on. All of the combinations have come in. So we've got serviceability as well as ULS. That's his Eurocode, by the way. And we can then move on and do design. So let's have a look at the size of this base. 1600 square, let's stick with that for now. 500, I'm going to make it, and we're going to say this is 750 deep like we had previously. We can put in here column details, whether it's offset or not. This is central. The soils, we talked about this earlier. Again, I had a, say, 200 there. And then we've got the dimensions I've just put in. The bar arrangements, I'm going to assume I need top and bottom. And then for auto design, I'm going to make sure I don't get a base less than 500 deep. And I'm going to tell it to aim for 16 mil bars, not just leave it entirely to the program. And hit the apply button. Right, so let's check that. Oh, you can see that's failed. The area still is not working. So if we go to the reinforcement tab here where the checks are, you can see here what's provided and what's required. We can see we're underneath there. Some of the other checks you can see here, these are for overturning and sliding. You can see the pass, the linear bearing pressures here, look. And you've got different combinations you can toggle through to have a look at that. So our reinforcement's not working. We've got 10s at 250, which is a bit light, isn't it? So let's do auto design. There we go. 16s I told it I wanted. That's what it's put in. And we go back to our check results now. Everything's hunky-dory, no problem at all there. Look, 866, 87%, and base done. Okay, so we're still in CADS A3D Max, but this time, instead of doing a single base like I did just now, we're going to group the bases together for a common design. You may, in practice, have corner bases different to the other bases here, but I'm going to assume they're all the same for purposes of this video. So there's all the bases selected, and we go to create base group, and we can put in here some description of what we've got, all the bases, and move through the various tabs it gives us to answer the questions. Do you want them to be designed individually? Now this means they would all be different, but I'm going to come up with a common solution and hit finish. So we get the little view of our bases behind there, look, and they're all listed in this group member design dialog box. There they are, all listed there. So if we pick the whole set, we can go in now and have a look at some default data, some auto design data, just like we did in the standalone program. There's the grade of concrete and covers and so on, reinforcement types, soils, bearing pressure that we put in, whether it's drained and undrained, and some dimensions. Now I remember the base just now was 1600 square, and that seemed to work. 600 deep, 750 below ground, and then we've got a column coming in as we had before. The bar arrangements, I've got top and bottom, that's fine. I'm going to go for 16s. This is if I was checking it, but I'm going to do auto design anyway. 16s at 150, and then in the auto design, let's do something I haven't done. Let's fix the base so it doesn't go less than 500. And again, I'm going to tell it 16s are my preferred bar size, like so. So now we can do a check. So what this is doing is now checking that data, as we did in the program on its own. It's checking the data we've just put in to tell me if there's any problems. And when we ran the individual base earlier, it didn't work because of reinforcement. And sure enough, that's what it's saying here for all of these. They're all failing. You can see they're all red, failing. So now we want to get the program to do some work, and we hit the design button. So we just pause for a few minutes. So what the program's doing now, instead of designing each of them separately, which as you saw when I put this group in was an option if that's what you want to do, it's going through all the bases, and it's going to give me a common design for all the bases, so they all are the same. Obviously that saves a lot of time and effort and work and fabrication. And sure enough, you can see, let's just open this up a little bit, you can see all the bases have gone that very attractive shade of green, which means there's no errors. It's giving me utilization ratio, that's the best one there, look, that's this one here. And the others are all in their 80s at least. Critical load combination and the critical design mode of failure, so pressure, reinforcement or whatever. You could go into any individual one and have a look in detail if you want to, but that's designing a series of bases in batch in A3D Max. Okay, so we're in CADS RC now. We're going to pass the design information from one of the bases we've done in this video into CADS RC for automatic RC detailing and scheduling. The CADS RC program can be used generally speaking, to put bars inside any outline and you get a schedule. But the benefit of the link is we don't have to do any of that work. We just literally have to point the macro here for pad bases at the design information we just generated. These are in CADS RC, but you'd still have to put in all the design details. We're just creating what we call a member title in CADS RC. It's part of the database information. So we're saying here that this base is repeated 20 times on site. So we can just detail one and the schedule will take care of the rest. Now, ordinarily, if you're using it standalone without the design input, you'd have to put all this information in. But all we have to do is pick up our design file, CADS RC base designer file there, bring it in and say draw. So you can see, we go okay there, you can see it's brought one of the bases in, the one with the skewed column look. There we go. That's the base with some U-bars in it. And then finally the column. There we go. So let's have a quick look at that. You can see we've got the 16s I wanted in there earlier. All the bars are detailed and there's a base detail there. Okay, so there's the actual detail. Now if you want the schedule, just go down to schedule here and there's the bars, then go to report. These reports can all be customized, of course. You don't need, well, you can if you want to, but you can change the logos and everything from CADS to suit your own company, of course. There we go. And there's even a weights report and so on as well. So this is what we would use, generally speaking, for detailing general work, but this is showing you how it works for a specific element such as the RC base designer. Okay, I hope that's a bit of interest. If you need to see this in any more detail, then obviously we'll give some contact details at the end. Okay, thank you very much for spending some time with me today to look at CADS RC Pad Base Designer. You can see the other programs in the suite. There are other videos to show you some more details of these. CADS Hub is a new interface that we've developed. In there are a couple of concrete programs for TR34 checks, ground bearing slabs and punching shear design. Again, these are standalone programs. And then if you really want to go into full 3D design, we have a deal now. We are a partner with Dubal. We can then do finite element analysis and design, and that takes us to this new level, as you can see, literally flat slab design if you want to do multi-story buildings, or indeed concrete water treatment tanks, circular tanks, all sorts of complicated structures that we can do with that suite of programs as well. Indeed, we've 2D slab program as well, so that we can do individual flat slab program, flat slab design, or even piled rafts, for instance, foundations or supported slabs, and even a link then to the CADS RC 3D program for Revit for detailing. So any questions regarding those other programs, or to find out more details about the program you've seen today, there's a phone number there to ring, email to send us some messages, and a website you could visit to get more details there too. Any feedback would be appreciated. I can honestly say we act on it very seriously, and feedback's very valuable to us. So again, your time is also very valuable. I appreciate what you spent with us. Thank you very much. I hope to speak to you again. All the best. Bye-bye.